Morning students, my name is Daniel Barnard. I'm the fluid technician here at CPUT, and I'm going to go through the lab calibration of Rotameter with you. I will go through the lab guide, and then I will go into the lab showing the equipment, how the data is captured, and tell you what will be provided for you to do the actual lab. Then once all that is done, you need to answer a questionnaire on Blackboard, and all the links to the videos and data and questionnaire will be provided by a lecturer. So next up, let's have a look at the lab guide. Okay, so this is what the lab guide looks like for the calibration of the Rotameter. Next, we'll just have the table of contents. And on the next page, obviously the very first part is the aim of the experiment. What is the purpose of the experiment? And it very clearly states is to calibrate the Rotameter fitted to the mechanical fluid mechanics test bench. Then the second section, what you need to do. Please read through that carefully on what you need to do for this lab, and it states very clearly what needs to be done. Then the next section is just a theoretical background. Here you can see a diagram of the Rotameter and all its parts and the important parts, and there's a short description. Next page is a picture of the hydraulic workbench, and there you can see the Rotameter is fitted to the workbench, but obviously in the next video I will show you the equipment and you'll have a better understanding. And then we have an experimental procedure which I'll go through on the next video as we go through equipment, then results. It's saying what we need as a result, and this one just needs to, you need to plot the flow measurement versus the Rotameter height, and then at the bottom is a short description of the data, what you will receive and what needs to be calculated. Then on the last page, the appendix is a data table. This is the example of how the data will be supplied. So in the first column you'll have float height, time in seconds, volume and flow rate, and then there's also a short description on the data that you will receive. And then on the very last page there is some further reading for you to do. Here we can see the hydraulic workbench, and I want to go through each part. So inside, there at the bottom we have a pump, and it's standing inside water. It is the main tank. Then it pumps the water through the Rotameter and through that pipe, and then the water drains into a small basin again, and then from the small basin back into the main tank. Here I have the on-off button. Here I have a sight glass for the basin, meaning the water level we see here on the sight glass would be the water level inside the basin, and then this pipe at the bottom is the sight glass for the main tank, just to make sure there's enough water in the main tank for the pump to work properly. Now on the sight glass for the small basin, there is markings on it, increments. All that means, these increments are marked 5 liters apart. So from if the water fills from this line to that line, that is 5 liters of water. And here we have the Rotameter. There's the glass tube. There's some air coming through. And this is the float. And from the schematic you'll see this bottom edge of the float is where we take the reading. And the scale for this Rotameter is in millimeters. The reason why we need to calibrate the Rotameter, now the Rotameter is on 73, but it doesn't tell us how much flow is going through the system. So that is the reason why we're going to calibrate the Rotameter. In the next video, I will show you the procedure how to calibrate the Rotameter. To calibrate the Rotameter, we're going to put the Rotameter on reading 0, and then we're going to close this small basin with this plug. Now the water inside the basin will start to rise. And remember, these increments are marked 5 liters apart. So when the water reaches this line, I'm going to start my stopwatch. And when it reaches that line, I'm going to stop my stopwatch. Then I'll know how long it took to fill 5 liters of water. So we'll just wait a little bit for the water to rise. It's rising slowly, slowly. Right, so as soon as the water touches the line, I'll start my stopwatch. And that will be exactly 5 liters of water when the water reaches there, and then it's where I will stop my stopwatch. If I know how long it took to fill 5 liters of water on a rotameter setting of 0, I can determine the liters per second for the rotameter at setting 0. So once that is done, the next step would be to set the rotameter on 20 millimeters. So we'll go in increments of 20 millimeters. So that's on 20. We will drain the tank by taking out the plug again. Just wait for it to drain a little bit. And then we'll close it up again. And then we start the same procedure again. So you can see the water is a little bit bouncy at the moment. So we wait for the water to settle. And if it reaches that line, I'm going to start my stopwatch. And when it reaches the next line, I'm going to stop my stopwatch. And that is a measurement of 5 liters of water. If the water is very bouncy, you might have to wait for the water to settle, and you will only be able to take a reading from this line. So it doesn't matter which increment you use, all the increments is in segments of 5 liters of water. So we will continue this procedure and jump in increments of 20 millimeter each time and take the flow measurements. Once all the measurements are taken, on the rotameter, increments of 20 millimeters, all the raw data will be supplied to the student. Then it's up to the student to take the raw data, do the necessary calculations, and then do the lab itself. Then also you'll need to answer a questionnaire, of which the link will be forwarded to you.